An air intake in the nose, a swept wing, missiles on the fuselage, engines placed vertically, fuel tanks above the wing. This is not a school project or an aviation experiment. No, this is one of the most unusual aircraft, and moreover, one of the coolest interceptors of the Cold War. Hello aviators, Sky here, and today we're looking at the curiosities of the British aircraft industry. I present to you the English Electric Lightning. After World War II, jet aviation developed at a breakneck pace and gave aviators aircraft they could not have dreamed of just a few years ago. One of the leaders of this development was Great Britain, which had both the technological base and special priorities. London was one of Moscow's most implacable opponents and was preparing for a potential war, and the main threat to it were Soviet bombers. Unlike the United States, which is thousands of miles away, the United Kingdom was quite accessible for aircraft with red stars. The main priority of the Royal Air Force was to protect the island from long-range aircraft. First of all, it was necessary to cover the airfields on which the V-bombers were to be based: the Vickers Valiant, Handley Page Victor, and Avro Vulcan. What they needed was an interceptor, well-equipped, armed, and fast. Very fast. The military wanted a speed of at least Mach 1.5, about 1600 km per hour. Not bad, considering that fighters of the late 1940s were still subsonic. The program executor was English Electric, and the task before them was serious. They had to build a rather large aircraft, and accelerating it to Mach 1.5 with the engines of that time was only possible by playing with aerodynamics, and these guys played it out to the fullest. The engines were placed not side by side as everyone is used to, but vertically. And that's what you see, the nozzles. Inside the aircraft, the engines are not positioned one above the other, but offset. The upper one closer to the tail, and the lower one slightly in front. The fuselage is compressed as much as possible. The purpose of this arrangement was to reduce the cross-section area. From the side, it looks like a pot-bellied fish, but its frontal drag was a quarter less than that of classic aircraft. There were other solutions that compromised advantages and disadvantages. The wing was made quite large, equipped with advanced mechanization and unusual tips, which ensured good controllability. But its thinness limited the capacity of the fuel tanks. Due to the lack of space in the fuselage, the main landing gear was placed in the wing, which prevented any loads from being suspended there, forcing the weapon to be suspended from the fuselage. The tail stabilizer had to be moved away from the plane of the wing, and after much research, it was placed in the lower part of the tail. The heart is the most advanced, the promising Rolls-Royce Avon engines, which in the future will be very successful and used in many civil and military aircraft. A difficult dance, but it should have worked.
3, 2, 1, 0.
In August 1949, in the desert region of Soviet Kazakhstan, the RDS-1 device was used, an atomic bomb. Now Great Britain was threatened by Soviet long-range bombers, which had received nuclear weapons. In addition, the USSR was actively working on new bombers, transonic and even supersonic, which would have been much more difficult to defend against. Support for the English Electric project grew, as did the requirements. It now had to fly at speeds of about Mach 2. The assembly of 3 prototypes was carried out in 1953, and they were waiting for engines. The Rolls-Royce Avon was very good, and had only one drawback: it had not yet been created. The prototypes had to be equipped with the old Armstrong-Siddeley Sapphire engines. The problem was not only with the engines. Already at the stage of creating prototypes, it became clear that the project needed improvement. It was decided to create 3 more aircraft with the applied changes. This resulted in 2 groups of test aircraft, the early P-1A and the more advanced P-1B. Despite the fact that the P-1B was formally considered only a minor modernization, in fact they were redesigned very seriously, and the B index was more of a bureaucratic trick. kinda like the Soviet Tu-22 and Tu-22M, for which the index is the only thing they have in common. In addition to a huge number of component changes, the dimensions had also changed. The new version had grown and became heavier. Length 16.8 meters, wingspan 10.6 meters, height almost 6 meters. Maximum takeoff weight exceeded 20 tons, which means that in terms of mass and dimensions, it stands somewhere next to the Eurofighter Typhoon, which is a little smaller but heavier. In August 1954, the prototype made its maiden flight. A week later, it broke the sound barrier for the first time. The problem of a too small fuel reserve immediately emerged, and it was solved on the second prototype, which received an additional tank, giving the plane a slightly bigger belly. In 1957, active testing began on the updated P-1B versions. Here, all the new solutions showed themselves. First of all, the Avon engines, which gave a great thrust-to-weight ratio. So great that at the airfield, the pilots turned off one engine, since two at once, even at minimum speeds, could accelerate the plane to 130 km per hour. They had to constantly hit the brakes. But in flight, it was very useful. Supersonic ceased to be a barrier for the Lightning. I'll add more later. It also had a problem. The combination of voracious engines and a small fuel supply seriously reduced the flight range. At the beginning of record-breaking flights, this was especially upsetting. At maximum thrust, the fuel burned so quickly that the plane did not have time to reach maximum speed. The tanks emptied before that. Solutions were found, and aviators received their Mach 2, but the problem of lack of fuel and range of the aircraft remained chronic. At the end of 1958, the aircraft finally received its official name, Lightning. The first production version of the fighter was named Lightning F-1 and entered service in the spring of 1960. The fighters in the base were equipped with a 30mm Avon cannon. Plus, it was possible to install a couple more Avon cannons, unguided missiles, and the main caliber, de Havilland Firestreak air-to-air missiles. The onboard equipment was the most advanced. The aircraft received state-of-the-art automation, multi-mode radar, and advanced interfaces. But all these bonuses also had side effects. The aircraft turned out to be complex and expensive, both to produce and to maintain. It required a large amount of special equipment and highly qualified personnel. The layout of the power plant did not help at all. To remove the lower engine from the aircraft, you need to lower the engine down from the fuselage, and the upper one, on the contrary, needs to be lifted up from the fuselage with a crane, and then lowered. The inspections were as thorough as possible. Any leakage from the upper engine went to the lower one, which could easily cause a fire. All this required serious work, and it was more or less successful. In addition, the Air Force's transition to new aircraft was intensified due to the appearance of two-seat version. And curiously, the pilots in them sat not in tandem, but side by side. The Lightning versions F-1A, F-2, and F-3 appeared. The equipment was improved, a boom for aerial refueling appeared, and the newest Red Top missile was added to the list of weapons. On the F-6 version, the engines increased thrust to 73 kN in afterburner, and another exotic Lightning feature appeared. A pair of fuel tanks installed on pylons above the wing. It looks even weirder than the engines on top of each other, but there is logic here. We remember that because of the landing gear, it was impossible to hang anything under the wing, but the top of the wing was free, and tests showed that this configuration was quite workable. Side effect: speed limit is Mach 1.5, but this is a problem with all external tanks, which impair aerodynamics. Due to flight conditions and different tank configurations, the range varied greatly. The maximum flight range reached 2,000 km with additional tanks, and 1,500 km without them. At the same time, in supersonic combat mode, the range was significantly lower. The radius was only about 250 km. A modest figure, but for the main task of protecting airfields, this should have been enough. You can find many flaws with the Lightning, but one thing cannot be taken away from it. It was an excellent interceptor. Rate of climb? From the concrete runway to an altitude of 11 kilometers, the plane could rise in less than 3 minutes. The maximum speed was up to Mach 2. For a short time, Mach 2.27, 2400 kilometers per hour. And one more thing. The Lightning was capable of long-term horizontal flight at speeds up to Mach 1.2. Without the use of an afterburner. Yes, the plane, originally from the 1950s, had supersonic cruising speed, a feature of 5th-generation fighters, the first serial owner of such a skill. Altitude? In 1962, an international exercise was held, in which the British aircraft were to intercept the American U-2s, flying at an altitude of 20 kilometers. And while during the first flights the interceptors needed to at least reach the U-2, later they began to be limited. With good acceleration, the Lightnings could reach a dynamic ceiling of up to 21 kilometers and caught up with the Dragon Lady without any problems. There was other evidence that over the following years, later versions of the interceptors, driven into almost ballistic flight mode, climbed to 26-27 kilometers. And unlike the speed-obsessed mad birds of that time, it was perfectly piloted in all modes. Everyone who flew the Lightning adored it, and not just the British, who had to, according to the flag, but also other pilots. The Americans often compared it with the F-104 and other Century Series jets, and admitted that the Brit was good, in some ways even better than their machines. The disadvantages were short range and high cost. It was more of an exclusive, with narrow specialization. Of course, with the increase in numbers, the interceptors began to protect not only airfields at home. In 1967, the Lightnings went to British bases in Cyprus and Singapore. Plus, some of the planes were transferred to West Germany. They didn't have to fight Soviet planes there, but they definitely shot down one combat plane, their own. In 1972, an incident occurred in the sky with a Hawker Siddeley Harrier. The pilot ejected, but the plane continued to fly towards the communist East Germany. Having found no other solutions, the Lightning shot the Harrier down. Officially, in order to avoid diplomatic problems. In fact, they didn't want to give the enemy the latest vertical takeoff and landing aircraft. A funny incident happened in 1966. In the process of servicing the aircraft, the need arose to conduct ground tests. The pilots were unavailable, and since they only needed to do a few short runs, the engineers decided to figure it out themselves. The commander of the technical service sat in the cockpit and worked normally until he accidentally fired the afterburner. The plane accelerated very quickly and took off, with the canopy removed and the engineer sitting in a locked ejection seat, in his mind going through all the variations of the word fuck. But no need to be dramatic. The unlucky pilot knew how to fly a light aircraft. Plus, knowledge of technical documentation helped to understand the controls, and the plane landed successfully. There was no disaster. Damage came only to the Lightning's tail and the nerves of the military commission, which emphasized that pilots really should be involved in tests of combat aircraft. Despite the specificity of the Lightning, the newly born British Aircraft Corporation, which included English Electric, tried to sell the aircraft abroad. They created a multi-purpose F-53 variant, capable of reconnaissance and attacking ground targets, as well as the T-55, an export two-seat training version. It's difficult to call this export plan particularly successful, but there were still sales. In the 1960s, it was hot in the Middle East, and Saudi Arabia and Kuwait became interested in the interceptor. The former bought 40 aircraft, the latter 14. Service, both with the Middle Eastern monarchies and at home, was successful but not very long. Already in the 1960s, new vehicles began to appear, more versatile, long-range, and armed. Northrop F-5E and Dassault Mirage F-1 were replacing them in the Arab Air Forces, and in the UK, the F-4 Phantom II was being pushed hard. The Lightning was becoming obsolete, and this was increasingly obvious. From time to time, modernization projects arose, installing a various sweep wing, replacing equipment, and mounting new AIM-9 Sidewinder missiles, but nothing came to fruition. In addition, significant wear was taking its toll. When such vehicles as the F-15 Eagle and Panama Tornado began to conquer the skies, the days of the exotic interceptor were numbered. By 1988, all aircraft were withdrawn from service. A total of 337 units were built. Well, the Lightning wasn't shipped by the thousands and did not conquer the skies around the world. It was too unusual, complex, and expensive to become widespread. Is this bad? On the one hand, yes, but on the other, you won't complain that elite whiskey is too complex, expensive, and not mass-produced. In the end, the Lightning's main task was to prevent Great Britain from being bombed. Well, no one bombed it. Mission accomplished. And its compatriots paid tribute to the Lightning by forming their own fan base around it. Dozens of these aircraft are still kept in museums and private collections, and some even managed to fly. The memory is preserved in the model names of their heirs. The Lockheed F-35 fighter was named Lightning II, as the successor to the Lockheed P-38 Lightning of World War II, and yes, the BAC Lightning of the Cold War. Comment what you think about this interceptor, like and subscribe to the channel. And if you want to watch the videos early, see some exclusive behind-the-scenes content, or just support the channel, consider joining our Patreon community. Fast flights on unusual planes, and soft landings to you.